So today we're going to find the absolute value of a number line and describe addition of integers correctly using absolute value. So the first task that I would like you to do all on your own is looking at these three kind of situations. I want you to go ahead and just read the situation, use the number line beneath each situation, and do what the situation asks you to do. So I'm going to give you about 1 minute to think through and do that. For those of you who need a little help with north, east, south, and west, here's how I remember it. Never eat soggy waffles. That's the one. And that goes clockwise, so in the same direction as a clock. Never eat soggy waffles. All right, so go ahead and answer those three questions. Cool. All right, Jacob, what'd you do?
Well, from 0, I moved to the right 3 times.
Okay, so he moved to the right 3 times and maybe drew himself, this cute little stick figure over here. Hey, check me out. I'm 3 blocks east of the store. All right, what did we do for the second one? You want to see that zest, want to see those hands shooting up. A little too much zest. Jesus, what'd you do?
I went to the left 3 times.
Okay, so you probably drew yourself somewhere over here, 3 blocks away from the store. All right, let's go to the third one. This is the one that stumped you. I had a lot of good questions about this one. What did we do? Jaquan, what'd you do?
Stayed on the 0, stayed to the 0.
You stayed on the 0? All right, so he's saying he stayed here. Is he 3 blocks away from the store if he's there?
No.
In the middle? Nope, so that doesn't work for us. But I see what you were thinking. Yes?
3 blocks to the right.
Okay, so Giselle draws herself over here. Jacob, what'd you do?
I think there's 2 ways to do this.
Okay.
To the left 3 times and to the right 3 times.
To the left 3 times, to the right. Okay, so he's saying that he's adding this to his answer. Did anybody do anything different? It's going to happen in the last lesson because it hasn't happened yet. Every year, there's somebody who does this. They draw a vertical line and they go 1, 2, 3, and they draw themselves up here, 3 blocks away from the store. Kip, yes or Kip, no? Are all of these answers right?
Yes.
Yeah, 100%. All of these answers are right. And so what you've actually just demonstrated is the difference between what we call a vector and a scalar, or the difference between a number and its absolute value. Okay, so when we talk about this in physics terms, we talk about these first 2 questions being what we call a vector. And we call them a vector because they have direction. How many of you seen that movie, Despicable Me? Right, the character's name is Vector, and he says because he's doing crime with magnitude and direction. All right? So, exactly, just like that. So, what a vector means is that it has direction. Well, however, we see the direction here in our information given to us, but in this other one, we're given no direction. And so that's what we would call in science or physics, we would call it a scalar, but it's also an excellent representation of what we call absolute value. It has no direction. It is simply telling you that you are a distance away from the store. And it doesn't tell you what direction. So, our definition of absolute value is how far away from a point. And generally, if we don't tell you what that point is, we're talking about 0. And in parentheses here, I'm going to add on to it, just kind of this extra piece, is that it has no direction. And in math, when we're talking about direction, what is it that tells us a direction? Mathematically speaking, what tells us the direction that something is going? Yesterday, when you were drawing your arrows for additions of integers, how did you know which way the arrow was going to go? Jason? Addition or subtraction, kind of pushing that forward even a little bit further. Jacob?
The direction it tells you. So also if it's negative or positive.
Negative or positive. That's a direction. Negative or positive is a direction. And so when we talk about numbers, if we just look at a number, it's assuming that positive is forward and negative is backwards. However, absolute value is kind of saying, hey, you know what? It doesn't really matter. I don't really care. So when we look at this, if we want to find the absolute value of a number, and these little vertical brackets here mean absolute value. If I want to find the absolute value of negative 5, I'm going to come to negative 5, and I just want to see how far away it is from 0. So I'm going to come over here to 0. And notice I'm putting double arrows on that. So why would I be putting double arrows on that? Instead of putting an arrow in just one direction. Sammy? Yeah, it's worrying about distance, not direction. So here I am simply worrying about distance, and I'm putting the arrow both ways because I'm saying it doesn't really matter which direction it's going. I'm only worried about counting that there are 1, 2, 3, 4, 5 units in between. The distance is 5. The absolute value of negative 5 is 5. All right, well, let's try it with 8. So 8, trying to figure out how far away it is from 0. Again, I'm going to show this with my arrows going both directions. So if you look back at our aim today, part of our aim is talking about being able to show it on a number line. Part of showing it on a number line is showing that it doesn't matter which direction, and I'm going to count 1, 2, 3, 4, 5, 6, 7, 8. The absolute value of 8 is simply 8. Doesn't even matter what direction. And that's kind of the idea with absolute value, is that it's trying to give you an idea of what direction, or that there is no direction, just how far away something is. So, over here, I have 4 problems that I think that all of you can use your intelligent 7th grade brains on, given the information that you have just been given, and I want you to show your work and tell me what the absolute value is for each point that's plotted on the number lines. Show your work just the way that I taught you, and then write your answer in the box. We're going to look at some things that we've been saying for quite a while that just aren't quite correct. All right, so we're going to look at this first problem. This first problem says 24 plus negative 38.5. The question is, what is the sign of the answer? So really quickly, think through your heads and then raise your hand. What is going to be the sign of the answer to this addition problem? Dahlia. Negative. And Dahlia, why is it negative? The negative 38.5 is greater than the 24. So a lot of the way that we used to say this is you used to always say, take the sign of the larger number, right? And then I saw Katarina over here when we were saying that, giving me a no. So we're going to check in with that in just a second. Katarina, why the no? Why the kip no?
Because isn't the positive numbers larger than negative?
And this is exactly why that's wrong. So we've been teaching you for a long, long time to take the sign of the larger number, but that doesn't really jive with reality because we know that positive numbers are always bigger than negative numbers. So really, if we're thinking about this accurately, and we want to be 100% accurate, that's not really the larger number, all right? So positives are always larger than negatives. So if we were taking this at exactly the way it's told to us, if I told you to take the sign of the larger number, all of our answers would be positive because positives are always larger. Kip yes or Kip no. Is it true? Is the answer to a positive plus a negative always positive? Listen to the question before you answer. Is the answer to a positive plus a negative always a positive? No. So take the sign of the larger number is not necessarily true. So what I hear us trying to say is we're trying to say that we want the number that is the most negative or positive. Which one is furthest from 0? Oh wait, furthest from 0. We just used a word to describe that.
38.5 is farther from 0.
Okay, so now she's trying to describe it. She's saying, now I'm looking for the number that is furthest from 0. She's changing this to say, instead of taking the sign of the larger number, I want to take the sign of the number that's furthest from 0. And we just learned some new vocabulary to describe how far something is away from 0. Flores? Absolute value. So, if we kind of take that all together, now instead of taking the sign of the larger number, we want to take the sign of the number. I'm going to use this little pound sign for number with larger absolute value. And that's what we call accuracy. All right? There's no confusion there. When we're talking about the number with the largest absolute value, doesn't matter negative, positive. We're talking about the one that is the most negative or positive. Is there more negative or is there more positive? So we're going to change the way we talk about that from here on out. Now let's look at this other one. I just taught you this. Just taught you this yesterday. And I've led you to write something down that could possibly be rather confusing. So today we're going to talk about a more accurate way to write it. So looking at this, we have -5 plus -4. What would you normally write in this first sentence? Can somebody just read to me what they would normally write for this first sentence? I'll give you a second to think about it. Go ahead and fill it in, so all you have to do is read it for me. Ivana, how would you fill in this sentence normally? To the left of is negative. Now, here's why this is really confusing. If I'm looking over here and I'm looking at this, it says -4. Wait, negative. That's telling me a direction. Units to the left. Wait, that's a second direction. Units to the left, negative. That's like me going to tell you to go up to the corner, turn right and left. What? Go up to the corner, turn left and left. What? So what we have here is we have multiple directions in here because that negative sign is telling us a direction. It's almost kind of like those are inversing each other. We would say a negative tells us that we're supposed to go left, but then you're telling me to go left again. Does that mean I'm just turning all the way around? And it starts to get really confusing. So we don't actually want to worry about which direction we're going here. We're going to say, you know what? If I'm telling you to move right or left, let me just give you a single direction here. Let me just make this a single value. Now that I've described this as the absolute value of 4, now I'm saying, hey, you know what? Hold off. I'm going to tell you what direction you want to go in a second. I'm just telling you you're going to be moving 4 steps. Now let me get to it. You're going to move 4 steps to the left. Instead of it saying, move 4 steps to the left, to the left. Got some Beyonce action going on there. To the left, to the left. Instead, we want that one direction going on there, where I'm only giving you a single direction about where to go. Okay? So that's what this does for us. We can use absolute value to describe distance when we want to give a direction about that distance later. All right? So somebody paraphrase for me really quickly. What was wrong with, or what was somewhat misleading or confusing about the original directions that we gave there? Terrence.
It gave us 2 directions.
Yeah. It gives 2 directions. All right? So, that's really isolating in on, if you can use absolute value in those 2 particular cases, not only do you know the basics of how to find the absolute value of a number, it clearly shows a distinct understanding that absolute value is only talking about distance. Okay?